Hello, Science 8. I just want to start today's class by going over the questions from the previous class. We had started um, with two sets of questions. Some of you got confused, and I think you thought there was only one set of questions. There were two sets of questions, 1 to 6. Again, make sure you continue to submit the questions. Again, they are for completion marks. So the class that we had looked at last had to do with mirrors. Okay, so the first question here: what size does the image in the plane mirror appear to be, and what distance from the mirror does the image in a plane mirror appear to be? So first off, a plane mirror is just a straight mirror, right, like a ruler. So if you look at the previous page here, this is a good illustration. The object, so that's what's in front of the mirror that's being reflected, and the image, what you see when you look at the mirror, they're always the same size. Okay, and the distance of the object to the mirror is the same as the distance from the mirror to the image. Okay, so that distance is always the same. Again, there's not actually anything behind the mirror, so the term we use for that is we say it's virtual. Number 3, how is a concave mirror shaped differently from a plane mirror? So a concave mirror is curved inward. Some of the uses for a concave mirror, so it's essentially where you kind of want to concentrate the light. So something like car headlights, a makeup mirror, these would be examples of concave mirrors. A convex mirror is curved outwards. Uses for a convex mirror, so like right here, you see that's a safety mirror, a security mirror in a store. And then you notice this phrase here if you look inside your car. So on like the rear view mirror or the side view mirrors. So it's what you see here is you're able to take a lot of objects and fit them into the mirror. Okay, the second set of questions were these 1 to 6 here. Okay, so number 1, how does the image change as you move closer to a plane mirror? So the image, in terms of the orientation, so the orientation has to do with is the image upright or inverted, upside down. So it stays in the same orientation, and the size of the object in the image stay the same. Now for a concave mirror, so the concave mirror, this is the one where I kind of had you figure out on your own. So this is, if you look at this illustration here, it shows you what's happening as you're going, here's your object, as you're going far away from the concave mirror and you're getting closer. Okay, so far away, what's happening is you get an image that's reduced in size, so it's smaller, and it's upside down or inverted. Okay, so the orientation has changed. As you get closer, the object, the image gets larger and inverted, and then as you even get closer still, the object is upright and it is larger. Okay, so again, just follow how the object is moving and how the image is changing. For the convex mirror, so the convex mirror is always, regardless of where you are, is always the image is always upright and is always smaller, okay, than the actual object. Okay, so it doesn't matter where you are. Okay, number 2 here, one side of a soup spoon is convex and the other is concave, so it's asking you which side is which. So if imagine some soup in the spoon, the side that's holding the soup would be concave and the bottom of the spoon would be convex. Number 3, do they obey the law of reflection? No, that's only for the plane mirror. And remember, the law of reflection is the angle of incidence is equal to the angle of reflection. Okay, number 4, the difference between divergent and convergent light rays. Divergent means the light rays spread apart, and convergent means they come together. And then some ray diagrams here. So here's Here's one for the convex mirror, right? So there's your parallel light rays striking the convex mirror, and then these are the reflected rays, and they're diverging. Okay, so again, diverging means they spread apart. They're never going to intersect. And then for the concave, here's the concave. And so again, here's your parallel light rays, and the parallel light rays meet at a point. This is what we call a focal point. And the other thing to say here is this distance from the focal point to the mirror, that's called the focal length. Okay, and we'll kind of get into more of that when we talk about lenses. Okay, and then number 6, suppose you find a shiny metal bowl. Are you likely to see the reflection of direct sunlight by viewing the outside or the inside? So the inside, and is it more dangerous to look at the outside or the inside? So the inside, because it's more concentrated in the light. Okay, so let's look at the next part here, which has to do with lenses. So there's two types of lenses. Okay, I got a comment for the previous class that some of the writing here is a little bit hard to read. So I'll read as I go through the notes here. So again, you should copy these notes down and keep all your notes together. So we're looking at types of lenses. So a lens is a curved piece of transparent material that refracts light. Okay, so a few terms here. So transparent. So remember, there's 3 behaviors that light exhibits when it hits something. It depends on whether the material it's going through is transparent, translucent, or opaque. So opaque means that it's not able to penetrate. So like a tin can, it would be opaque. The light can't go through it. Translucent means that the light is able to go through, but then what happens is you have a scattering effect, which kind of alters the way the light comes out on the other side. So that would be something like wax paper, right? So like say you had red wax paper, the light would hit it and then it would come out red on the other side. Transparent means the light's able to go through, right? So like a window, right? So completely go through. And then here, this is lens is different than a mirror. A mirror is going to reflect the light, so the light's going to bounce back. A lens is going to cause it to refract. Remember, refraction has to do with the bending of light. And the reason why light bends is because it changes medium. So in this case, it would be like air to this lens, right? And so suppose the lens is made out of plastic, right? So there's a change in medium. Okay, there's 2 types. There's a concave lens. So one of the things that's kind of confusing here is that we're using the word concave and convex like we did with the mirrors. So really try to distinguish between the lenses and the mirrors, even though they both kind of have that concave convex word in front. They're totally different. Okay, so you don't want to mix them up. Okay, so here's a concave lens. Okay, and so what's happening here is there's your parallel light rays. They're hitting the lens, and then what's happening on the other side is you have diverging rays. Okay, so the rays diverge. The image formed here is always going to be smaller and is always going to be upright. Okay, so one of the applications that we'll look at with the lenses has to do with like eyeglasses, right? What people use to be able to see better. People have typically two different types of vision problems. Either they have difficulty seeing things that are close to them, or they have difficulty seeing things that are far away. So I'll kind of have you think about that and think about which lens would be more useful for which particular situation. Okay, so the second one is the convex lens. So the convex lens here, what's going on is, so it sort of looks like an oval. Okay, so there's your parallel light rays hitting the lens. And then what happens first is the light rays converge and they meet up to the point called the focal point. And so this, again, the focal point to the center of this lens, that's called the focal length. So sometimes what we talk about is 2 focal lengths, 3 focal lengths. It's a way to measure distance. And basically, like if we say 2 focal lengths away, then what we're saying is you're at a distance twice a focal point. Okay, if we say 3 focal lengths, then it's 3 times the focal point. And then what happens after the focal point is now the light rays start to diverge. Okay, so what's going on here is the resulting rays first converge at the focal point, then they diverge. And then here, just like with one of the mirrors that we talked about for the last class, the resulting image depends on the location of the object. So where the object is going to dictate what type of size and orientation it has. Okay, so in terms of what the vision, the image is going to look like. Okay, so again, keep all your notes together. Remember, I had mentioned the office hours, right? So the office hours are Tuesday, 8:30 in the morning to 9:30. So that's if you want kind of live, real-time messaging. So if it's something that's really important, you need to kind of get the feedback right away. That's the time to do that. Otherwise, just continue sending messages whenever you're able to, and I'll be able to get back to you as soon as I can. Hopefully, you're kind of getting more used to and comfortable with the technology. My ideal way for you to submit work is through the assignment section. Okay, and so try to use that assignment section on the My Teams application there. Okay, so I'll give you some questions to work on with the lenses, and again, take a picture of your answers, and then you can submit them back to me. Some of you are doing your answers on computer and then just sending them that way, which is fine. Okay, so I'd like you to do the questions on this page 197, 1 to 11. So I know some of you have a textbook at home. Some of you probably left it at school. Okay, so you can just freeze this so that you get the you can do the questions on a separate sheet of paper or on a computer, and then just hand them into me. So there's 1 to 7, and then there's 8 to 11. Okay, so do questions 1 to 11, and then submit the answers to me. So I am keeping a tally of your completed work, and then also so that's part of your completion marks, and then also marking the assignments that you submitted. Like the only one that we've done so far was the coronavirus assignment. Okay, and like I said, if you're still having difficulty with the technology of how to kind of do all this, just make sure that you send me a message, and I can help you with that. Also, if you have friends that are in the class, I mean, you could always ask them as well, and see if they can kind of help you out with the technology part of it. Again, just I recognize that these are stressful times. Just try to look after yourself, look after the people in your household, and try to stay positive. Hopefully we will. This won't last too much longer, and we are able to get through it. Okay, so again, have these questions done, and then submit the answers to me. Okay, and we'll have the next class will be on Thursday, right? So typically Monday and Thursday is when I'll be doing the uploads. Okay, bye for now.